Hi folks, welcome to this webcast. My name is Florian from iProcess, and today we talk about system integration and the challenges that arise in complex mechatronic systems. This video is focused on engineers new to the topic of complex systems and the integration. I'm sure you seasoned systems engineers out there will know all these things already. So to get started, let's have a quick look at the V-cycle system development. Over here, you see the step system integration and system integration testing. So what does that mean? A system is woven together out of components. These components provide a functionality or a part of a functionality to the system. Components have interfaces. You can group them as follows. There are exactly two directions for the interfaces, in and out. No surprise here. Some components might not use both of them, by the way. The interfaces can be different nature. There are analog signals as well as digital communications. The analog signals, for example, are coming from a sensor that translates the physical information into a voltage. This voltage is then consumed by the component, and the software can derive the physical information out of it. Digital communications in automotive is usually bus communication. Bus communication is following a specific protocol and allows two or more components to exchange information. Typical buses in vehicles are CAN for multi-component communication and LIN for primary to single or multiple secondary communication. There are other buses out there such as CAN-FD and FlexRay, as well as Automotive Ethernet to handle higher bandwidth requirements. Next to analog and digital interfaces, the components also have a mechanical and an electrical interface. Mechanical, for example, for the mounting and physical force or torque delivery. Electrical for the integration into the vehicle's power network. So we have all these components, and they're doing their part to provide the functionality to the vehicle. Traditionally, those are very few controllers with very specific and defined roles. They were mainly contained in their own functionalities and used external inputs to provide these. The development and validation is in the responsibility of the supplier and the OEM, then putting the pieces together to integrate the vehicle, including their level of integration testing with regards to the interfaces mentioned before. Nowadays, there are two challenges arising with this concept. First, what was once a few controllers has been growing into up to 150. And second, many functionalities are no longer limited to a single controller anymore. Here's an example. Early electronic cruise control systems were solely based in the motor control ECU and thus had some weaknesses such as overshooting on downhills. In a modern electric vehicle, there are several controllers involved in cruise control, such as brake and regen synchronization, motor control, ADAS, user interface, to name a few. The OEM challenge here is that these controllers usually come from different suppliers, and the development is performed separated. In short, the OEM receives components towards the end of the development cycles. They are developed and tested based on requirements and interface specification, and they perform a Big Bang style integration test. I would assume that about 80% or more of customer-facing issues are rooted in problems with the integration of these components. The newest trend in the industry is the move over to domain controllers, where more powerful control units are the home for what was once a handful or more ECUs. This is a topic for a different video though. So what is the solution for the system integration challenges? The answer may sound simple, but it's not as simple to switch to. For some OEMs may be easier, for others harder. System integration has to be performed much earlier and with way more iterations throughout the development cycle. OEMs and suppliers have to move closer together in their collaboration. That naturally means that there will be failing integration test rounds in the early phases, which is expected but has to be adopted into the mindset of all the parties involved. By the way, that does not imply that agile development model has to be applied. There are also successful ways utilizing a multi-V cycle, as most OEMs and suppliers are doing anyway internally. iProcess can help to create strategies and streamline existing processes towards the common industry goal: better products and happier customers.